So in this question, we are told that the curve C with pole O has a polar equation r equals to 1 plus cos theta. At the point A on the curve C, the tangent C is parallel to the initial line. So if you are told it's parallel to the initial line, you know that at that case we're going to set dy d theta is equals to 0. So which will mean that at any given point you hear d parallel to the initial line, you are going to say that's dy d theta is going to be set to 0. But if you are told that if you are told is perpendicular to the initial line, set dx d theta is equals to 0. So those are conditions that you must know at that given point. So meaning that in this particular question, of course, the sketch of this curve is given by this. So which means that if we are going to work out the coordinate A, it means that we must set this dy d theta equals to 0. Now once we have said that, we are going to get it. So but we have to find now y, and remember y. So we are going to find y, and y is actually usually r sine theta, but in this case we are given r is equals to 1 plus cos theta at this given point. So that means our y becomes 1 plus cos theta times sine theta. So which means that if we multiply this, we are going to have y equals to sine theta plus cos theta sine theta at that given point. So once we have this, remember we are having y equals to sine theta plus cos theta sine theta. So with this equation that we have here, and we have said that when you are told is parallel to the initial line, you are going to differentiate this. So we are going to differentiate this dy d theta. We are going to say that is going to be differentiating this. We are going to get this is cos theta plus, we are going to keep cos constant, we differentiate sine, and that's going to be cos theta. Differentiating sine, we are going to get cos theta, then plus, keeping sine constant, theta, we differentiate cos, we are going to get negative sine theta, right? So our dy d theta is going to translate what? Is going to translate to cos theta plus cos squared theta minus sine squared theta at that given point. So which means that we are going now to convert, this sine squared theta so that we have the same. So in that case, we can first equate this to 0 and say this is actually going to be cos theta plus cos squared theta minus 1 into bracket minus cos squared theta. I've converted these to 1 minus cos squared theta. Then we are going to say that is going to be equal to 0 at that point. This is going to be cos theta plus 2 cos squared theta minus 1 is equals to 0. So we need now to work out the value of this, and this is actually quadratic, so we are having 2 cos squared theta plus cos theta minus 1 is equals to 0. So we can now say let cos theta be equal to x. In that regard, I'm going actually now to to have a quadratic 2x squared plus x minus 1 equals to 0. Now solving the quadratic, you are going to get x equals to minus 1 or x equals to 1 over 2. So once we have that, we can be able to find the values of the value of theta, because if we had said that let cos theta be equal to x, now we can be able to find what the value of x is. So which will mean here that we are going to say now cos theta is equals to -1. So if cos inverse of -1 is going to be equal to pi, theta is equals to pi, which is outside the range, the given range. Remember, the range of the angle that we were given was this. So this theta is not going to be part of the solution. So we have another option. So we are done away with this. We are going to take theta. The second case, we are going to take cos theta is equals to 1 over 2. And in that case, if you find theta is going to be cos inverse of 1 over 2, and we are going to get our answers plus or minus 1 over 3 pi at that given point. So meaning that, and if you look at the range, if we take negative is outside the range, so therefore theta is going to be equal to 1 over 3 pi. 1 over 3 pi is the required value of theta in this particular question. But now, since we are supposed to find the coordinate of A, so meaning that our point A is somewhere here, whereby it's actually pi over 3. So we need, because a polar coordinate has radius and the angle, so we need to find what the value of r in that case. Now, in order to find the value of r in this case, we are going to use this r we have here. R equals to 1 plus cos theta. So we are going to say r equals to 1 plus cos 1 over 3 pi. 1 over 3 pi. So if we work that out, you'll see what that is equivalent to. If I work it out, let me just try to use my calculator so that we can be able to see what that is equivalent to. 1 plus cos 1 over 3 pi. So if we work it out, you can see the answer we are getting is actually equivalent to what? 3 over 2. So this is actually equivalent to 3 over 2. So here this answer is 3 over 2. So that is the coordinate for this particular question. Then now, once you have worked that, you will be told now to work out the area enclosed by. So I want you to look at this as if your life depends on it. If you are told to work out the area here, you are told find the area enclosed by line OA. We were told that O is the pole. O is at that particular point. So OA, so this is the line OA, the initial line. This is actually called the initial line here. This line here is the initial line. And then now we are supposed to work out the area enclosed by the line OA, initial line, and the curve Z, the curve C. The curve C is this one that we have here. So meaning that we are working out the area of this part here. We are working out the area of this region. This is the region we're trying to find the area. Yeah, so now that's the region that you are supposed to find the area. So how are we going to find the area of the region? Now that we are done with this information that we have here, we have worked out the coordinate of A, we have gotten it. So which means that yours now is to ensure that you have written this particular part, so that anytime you want to refer, you can go straight and refer on the same. If you are new to Profilearn YouTube channel, consider subscribing so that anytime I'm going to upload a new tutorial, you'll be notified. All right, so something that you need to remember at this given point, for you to find this finite area that you are being told at this given point, the most important thing that you must know is the formula that you use to work out area of enclosed by a curve. So we know that area is given by a half integral of from alpha to beta of square of the polar equation and then the theta. So this is the formula we can use in order to work out the area of that particular part. But now you see, now this curve is starting from 0 degrees, increasing up to the pi over 3. So our range of integration is going to be, now our area is going to be a half integrating from 0 all the way to pi over 3. And in that case, our r is going to be 1 plus cos theta. Then we're going to square that. We integrate with respect to theta. So meaning that before we perform any integration at this given point, we are going now to say this is going to be a half integrating from 0 to pi over 3. So if we square this, we are going to get 1 plus 2 cos theta, 2 cos theta, then plus cos squared theta, so with respect to theta. So once we have this, we can now go ahead and try to work out and perform our integration. So we need really to make sure we make use of the space available in order to work out this. Okay, so but remember, we cannot be able to work with, if you are integrating, you cannot be able to work with this angle the way it is. Integrating powers of trigonometric ratios is actually going to be a little bit difficult for us. So meaning that we are going to convert that to double angles so that we can be able to work it out. So we are having 1 plus 2 cos theta, cos squared theta. So meaning that we can be able to convert. Remember, cos squared theta is the same as cos 2 theta plus 1 over 2. So meaning that we can be able to replace this part with this part that we have here. And this is going to be actually area is equals to a half integrating from 0 to pi over 3 of 1 plus cos theta plus 1 over 2 cos 2 theta plus 1 over 2 in that case. And this is going to be integrated with respect to theta. So integrating this, we are going to have our equation reducing to 1 over 2 into bracket. Integrating, okay, first we need to reduce this as well. This is a half, this is 1, and this is going to reduce to what? We're going to say now our area is going to be integrated from 0 to pi over 3. Now, 1 plus a half is going to become 3 over 2 plus cos theta plus 1 over 2 cos 2 theta with respect to theta. So at that given point, we need now to integrate this. And to integrate it, we are going to integrate term by term. And that is going to reduce to integrating 3 over 2. Integrating 3 over 2, we are going to get 3 over 2 theta. then plus integrating cos theta, you are going to get sine theta, and integrating cos 2 theta. Of course, we are going to differentiate this part that is inside here. We get 2, then we divide it here. So we're going to have 1 over 4 sine 2 theta. And the limits of integration. Let me just try to adjust this a little bit. The limit of integration in this case is going to be from 0 to pi over 3 in that case. So the business we have here is to substitute the values that we have. And remember, we are having a half here and we are having a half at that given point. So if we are going to substitute everything that we have here, we are going to end up having 1 over 2 into bracket. Of course, if you substitute, yeah, this is going to be, if we substitute this, we're going to have, let me just put this bracket, we're going to have 3 over 2 times this is going to be 3 pi over, okay, this will cancel out, so we are going to have pi over 2, then plus sine pi over 3 plus 1 over 4 sine, this is going to be 2 pi over 3, then minus 0. So that's what we are going to have, minus 0 at this given point, because if you substitute 0 to all these terms, you are going to get actually 0. So if you work it out, you are going to find that this is going to reduce to a half into bracket. Let me just check here. We have pi over 2 plus root 3, then plus this is root 3 over 8. So finally, we are going to have a half into pi over 2 plus 9 root 3 over 8. Yeah. Now simplifying this further, we're going to distribute this a half into the bracket so that we can be able to give it in the form that was expected at this particular point. So this is going to be equal to, this is going to reduce to, if we work it out, we're going to get pi over 4 plus 9 over 16 root 3. So that we can be able to conclude and say that our A is actually 1 over 4 and our B is going to be 9 over 16. So that is the answer that we were expected to give in this question. So what is the most important thing that you are supposed to do when you are given a question like this? The most important thing that you need to do is to sketch that curve, and then you go ahead to work out the area that are expected. So one of the advice I'm giving when you are doing with a question to do with the polar graphs, you need to know how to sketch various polar equations or polar curves. For instance, you need to know how to sketch Rosses, you need to know how to sketch Limassons, you need to know how to sketch cardoids like this, so that anytime maybe you are supposed to find the area, you can be able to know from which part of range of angles that you need to know, you need to use. So most important part also is the angle to be used when you are integrating. So that is quite important. You need also to practice more on the same. So we have come to the end of this particular video. If you are new to Proflan YouTube channel, consider subscribing so that anytime we are going to upload another tutorial like this, you'll be notified. See you in the next video.